Every sunrise begins with warmth. Light washes over oceans and rooftops, climbs hillsides, and settles on familiar places. Yet beyond that comfort lies a quieter truth. The wider universe is not a blaze of heat, but a long and patient cool. As we move away from stars, heat thins, motion eases, and the bright edge of day gives way to a vast and careful calm. There is a faint afterglow that belongs to everything, a leftover shine from the first light. It keeps space only a little above absolute stillness, about 2.7 degrees on the Kelvin scale, a low note held across the whole sky. Even so, in scattered regions across galaxies, the temperature falls lower still. Dusty clouds shelter their interiors from starlight. Lonely stretches between galaxies keep their distance from heat and hurry. Shells of gas breathed out by fading stars expand and cool like a long exhale. In these places, atoms move so slowly that motion seems to consider stopping. Cold here is not a punishment, it is a property. It is what matter does when light steps back and space gives it room. In that room, delicate processes become possible. Molecules can settle onto dust grains and wait. Gravity can draw threads of gas together without disturbance. Faint signals that would be lost in warmer places can be heard. If you enjoy quiet explorations like this, you can stay with us and subscribe for more journeys into the hidden workings of the universe. And if a thought arrives as we travel, share it with a friend or leave a gentle note below so we know where curiosity led you. Begin nearby in cosmic terms, with shadowed craters at the poles of quiet worlds. The sun never climbs above their rims. Light skims the edges and moves on. Over long seasons, the ground gives up its heat to an open sky and receives almost nothing in return. Frost can remain there for ages, grains of ice held in a stable hush. The lesson is simple and repeats everywhere. Shade invites stillness. Stillness invites cold. Step farther out to dark nebulae that look like smudges against the star field. Their outer layers see a little light and share it with the night. Their inner cores keep their shade and grow calmer. There, inside dust thick enough to hide a lantern, temperature can approach the deepest quiet nature allows. The cloud is not empty, it is preparing. The calm slows the dance of particles so that gravity can guide them inward with patience. In time, new stars will gather from this quiet, but for now, the light is elsewhere and the work is slow. There are hollows colder than the background itself, brief sculptures of breath and space. In some envelopes around fading stars, gas expands so gently that it cools below the universal afterglow. It is like a pocket of morning frost formed in the night sky, delicate and rare, a structure of calm set against a wider calm. These are among the coldest places we have measured, and they remind us that temperature in space is not a single condition, but a map of how light and matter meet, avoid, or release one another. Even the edges of galaxies hold a quiet of their own. Far from the crowded lanes of the disk, encounters are uncommon and gravity is softer. Gas radiates away its faint energy and receives little back. The cool lingers. The grand spiral turns, but its outskirts keep an even breath. Between galaxies, the distances stretch so wide that a particle can drift for a very long time without meeting a neighbor. In such stretches, heat has little to hold on to, and calm becomes the default. How do we know these things about places we cannot visit? We listen to long and gentle wavelengths and read what is missing from the light that reaches us. Cool dust shines softly in the far infrared. Cold gas leaves quiet lines on starlight that passes through. Each missing note is a clue. Each soft glow is a measure. With those clues, a picture emerges of a universe that is not only powered by fire, but shaped by frost. This is our journey. We will move from the warmth we know into the carefully kept cold that allows new structures to form, ideas to clarify, and signals to be preserved. We will look at craters that never see sunrise, clouds that shelter their own hearts, envelopes of expanding gas, outer halos of galaxies, and the laboratories where people on Earth cool matter to near stillness to learn what it can do. The coldest places in the cosmos are not merely destinations, they are principles written into space. They show how the universe stores its calm and how that calm lets creation proceed. In the lunar south, near the rim of a deep crater, sunlight never arrives. The terrain there lives in gentle twilight, its edges silvered, its depths untouched. Temperatures fall far below freezing, the ground a frozen record of time itself. Here, the absence of light is not emptiness, it is preservation. Every grain of frost, every small deposit of water ice can remain undisturbed for an age, held in a stillness so complete that even the warmth of nearby sunlight cannot fully reach it. When the first spacecraft measured these polar shadows, the instruments hesitated, unsure whether they were reading noise or fact. The results whispered values so low they bordered on the impossible. Colder than many far-off worlds, colder than anything humans had ever stepped upon. Yet the truth sat in plain sight, a patch of the moon with a chill that rivaled the cold between stars. Cold on the moon behaves differently. It is not the active bite of a storm. It is the passive stillness of a world that has stopped participating in heat. With almost no air to carry warmth and no weather to stir the surface, the only motion is the slow drift of infrared light leaving the ground. That quiet exhalation has gone on for eons until the heat was gone and silence remained. Planetary scientists call such regions cold traps, natural vaults where fragile materials, once delivered by comets or released by impacts, fall and never rise again. Within these traps lie some of the oldest preserved substances in the solar system, pure samples of beginnings. Water, ammonia, traces of other simple molecules, all frozen into quiet stillness, waiting for the day when light or human curiosity will disturb their rest. The same shadows that guard lunar ice stretch across Mercury's polar craters and the deep basins of small worlds like Ceres. Each is a monument to stillness, a dark museum of cosmic history. In a universe driven by fusion and fire, these pockets of calm hold the opposite principle, that absence can create endurance. Where there is no heat, time slows. Where there is no light, memory survives. The moon's frozen craters give us our first lesson in cosmic quiet, but the universe holds deeper silences still. Between the stars of a familiar constellation lies a black patch of sky that seems to erase the light behind it. To the eye, it looks like nothing, an absence among brilliance. Yet that darkness hides one of the coldest natural structures in existence, a dark nebula, a wide cloud of gas and dust that blocks starlight while cradling the seeds of new suns. Within these molecular clouds, temperatures drop near absolute zero. Atoms barely move. Collisions happen so slowly that chemistry becomes patient. Light cannot penetrate far, so reactions take place in a gentle dimness. Here, complexity grows quietly. Molecules assemble on the surfaces of frozen dust grains, water, methanol, ammonia, and traces of organics. These fragile forms could not endure in hotter regions of space. They need the cold. They need the slow patience that only darkness provides. Radio telescopes listen to these regions in frequencies too low for our eyes. The signals are faint, like whispers stretched across space. Every emission line marks a molecule releasing just enough energy to be noticed. When astronomers map these frequencies, a picture forms, not of stars, but of their wombs. From this deep cold, new warmth is born. Gravity begins to gather material, compressing gas until the temperature climbs again. A star ignites, its first breath tearing through the darkness that once protected it. The nebula, having completed its quiet work, dissolves into light. Creation requires both silence and burst, and the universe alternates between the two like a slow heartbeat. Among these nebulae, some are so frigid that they dip below the gentle background of the universe. Their dust radiates away energy more efficiently than the surrounding space can replace it. Instruments record them as darker than the sky's baseline warmth, a deeper quiet in an already quiet field. They are rare and fragile, brief sculptures in a wide emptiness. When we detect them, it is like finding an echo softer than silence. These clouds, unseen yet essential, remind us of a paradox. Life may owe its existence to regions where life itself could never survive. In these invisible laboratories, the ingredients of biology freeze together, preserved for the moment when light returns. The universe builds patiently, with the stillness of something that knows there is time enough for everything. Far beyond the spiraling arms of a galaxy, where stars grow thin and dust runs out, lies a region of quiet so profound that temperature itself seems uncertain. In the outer halo, atoms drift far apart, moving so slowly that collisions may take longer than civilizations endure. The light from the galactic center arrives weak and red, stretched thin by distance. Gravity still binds everything together, but gently. It is a careful balance, motion on the edge of stillness. These halos are ancient reservoirs of cold hydrogen, the raw material from which galaxies once grew. They are the ghost outlines of cosmic giants, still tracing the shape of what they were. From time to time, a passing galaxy disturbs the calm, drawing thin threads of gas into bridges that span space. These bridges can extend for great distances, yet are so diffuse that a traveler could pass through them without touching a single atom. Between galaxies lie great voids, enormous cavities of near-perfect emptiness. There are no suns to warm them, no dust to hold heat, only the faint afterglow of the beginning, stretched and thinned until it becomes a constant murmur. In these voids, the universe reveals its true character, not fire, but quiet endurance. New telescopes have begun to trace faint galaxies forming along the borders of these voids, like frost outlining invisible glass. Their light travels for ages to reach us, a whisper from a time when the universe was young and cooling. Each photon carries a memory of that long descent into stillness. When we detect it, we are catching the past in mid-motion. In the cold outskirts, time behaves differently. Processes that on Earth would take seconds can unfold over millennia. Dust may coagulate into pebbles over the span of cultures. Magnetic fields evolve so slowly that they appear frozen. If we could stand there and look back toward the galactic center, we would see the warm heart of creation glowing faintly, surrounded by vast darkness, heat confined to a small spark in a sea of calm. The silence of the halo is not lifeless. It is a structural necessity, the counterweight to creation's fire. For every star blazing in the center, there must be regions where energy dissipates and motion ceases. Without the cold, there would be no balance, no space for light to exist at all. Cold is the architecture that keeps the universe from collapsing into chaos. In hidden rooms on Earth, humanity has learned to imitate the silence of deep space. Metal corridors lead to sealed chambers where air has been drawn away and stray light is counted carefully. Inside, the temperature falls to billionths of a Kelvin, colder than the space between the galaxies, where the background still whispers at about 2.7 degrees above absolute zero. No place in nature is this cold. Not the shadowed craters of the moon, not the voids that span across space. Only here, on a small blue world, do temperatures this low exist. In our curiosity, we have created the coldest corners of the universe. Those who first reached these realms did not know what they were truly making. In the 1990s, a handful of teams learned to cool gases with light until they reached a point where matter behaves less like particles and more like waves. It was a victory so quiet that even the atoms ceased to make sound in any way we could hear. Stand before the glass of a cryogenic chamber and you will see almost nothing. The air is gone, the light arranged to keep from warming the scene. Yet inside that apparent emptiness lies a pocket of pure truth. The motion of every atom is counted and predicted until it is not. At these temperatures, quantum uncertainty becomes visible. Atoms spread out and overlap like ripples on still water, merging into one coherent whole. The result is a Bose-Einstein condensate, thousands of atoms stripped of individuality and acting as one wave of existence. It is the closest we have come to holding the unity of the cosmos in our hands. We build colder and colder chambers, not only because we can, but because we're drawn to silence. The same silence that lives in the shadows of lunar craters and in interstellar voids now appears in steel vessels under soft lights. Each small drop in temperature brings us closer to understanding what the universe becomes when motion fades and heat, the pulse of creation, falls quiet. These laboratories are paradoxes. To make nothing move, everything around it must move perfectly. Pumps roar, magnets hum, lasers align with careful precision. The room stirs with activity so that inside the small chamber, all can be still. It is a human echo of cosmic balance. Commotion outside, calm within. If we could shrink ourselves to the scale of a single atom and drift into a Bose-Einstein condensate, the boundary between self and surrounding would vanish. Every atom we touched would be the same atom, part of a single, undivided wave that stretches through the chamber like a thought. It is matter dreaming itself. At these temperatures, only a few billionths of a Kelvin above absolute zero, atoms no longer behave as separate things. They merge into one quantum state, a fluid that can move without friction and without loss. This is the universe's version of sleep. In ordinary gases, each atom is an independent wanderer, colliding and bouncing and exchanging energy. As the temperature falls, collisions become gentle whispers. Motion slows, identities blur, and the crowd of particles begins to act as one. To the eye, a condensate looks like a faint ghost of light. Under magnification, it shimmers, a droplet of near-nothingness held in magnetic fields. In that near-nothingness lies a clue to everything. The condensate behaves like a single superatom. Push it, and it moves as a whole. Split it, and both halves remain connected through coherence. Interference patterns reveal the invisible links binding every atom together. Here, the boundary between physics and philosophy grows thin. In this state, individuality dissolves. Each particle becomes part of a greater unity. The universe itself may have once been in a similar state just after its birth, when all matter existed as a single field. To cool atoms to this degree is to rewind cosmic history and glimpse the calm before variety. Deeper in, stranger behaviors appear. Light itself can be slowed, even paused inside a condensate. A small pulse enters the cold vapor and rests there, held still by the cooperative atoms. Release the field, and the light resumes its journey as if no time had passed. In that moment, we watch information pause, a memory stored in frozen matter. The deeper we go into this cold, the more the universe seems to whisper that stillness is not death. It is the pause between breaths, the interlude that allows creation to think. When atoms sleep, they do not dream of heat, they dream of order. Each phase aligns, each vibration harmonizes, until the chaos of normal matter becomes a choir. It is a state of symmetry, fleeting in the lab, yet eternal in concept. If we could look far into the future, past the burning of stars and the collapse of galaxies, we would find a universe almost completely dark. The gentle afterglow of the beginning would fade below sight. Temperatures would sink from about 2.7 degrees above absolute zero to fractions beyond ordinary comprehension. Only the blackest remnants of once brilliant suns would remain, cooling slowly across spans of time that exceed imagination. These dead stars, sometimes called black dwarfs, would be colder than any substance known today. Their atoms locked in near-perfect stillness, their like long gone. It would be a universe held in quiet balance. No sound, no heat, little motion. Yet even then, stillness would not be absolute. The rules of the small refuse to allow it. In the final dark, brief flickers would appear and fade, stealing energy from the vacuum. Over unimaginable ages, even black holes would evaporate, dissolving into radiation too cold to notice. This is how existence may end, not with fire, but with surrender. The universe would not collapse or explode. It would drift into stillness so complete that meaning itself would seem to dissolve. And yet, somewhere inside that endless frost might lie the seed of beginning. In every experiment at the lowest temperatures, something unexpected happens. As atoms lose motion, they begin to behave as one. Unity arises from absence. The less energy a system has, the more coherent it becomes. If this principle holds for the cosmos, the coldest possible future may not be death at all. It may be rebirth, the universe finding its next order in silence. The coldest places in the cosmos may therefore be the universe thinking. Each void, Each frozen star, each atom held nearly motionless, another neuron in a mind too large to imagine. Our instruments cannot see thought, but when we observe the cold, we witness something more profound than emptiness. We are seeing what remains when everything else has been stripped away, the simple geometry of being. Across wide stretches of space, the universe hums with fading warmth. Every dying star and every whisper of radiation is a memory, a note in a song slowing toward silence. Yet silence is not the end. It is the breath the universe takes before speaking again. In laboratories on Earth and in the dark between galaxies, cold teaches the same lesson. Stillness reveals truth. When motion fades, patterns appear. When heat vanishes, order returns. The cold is not absence, it is memory and balance, and the quiet rhythm beneath creation itself. So when you look at the night sky and feel the air still around you, remember that you are seeing the calm heartbeat of existence. Because even in the coldest places in the cosmos, something endures, something watches, something waits to begin again. If this story moved something in you, share a thought and pass it to someone who loves the night sky. Thank you for journeying with us. Stay curious.